Greetings. I'd like to discuss the use of 2D quant. In other words, you don't have a mass spec as shown in this picture here. You're just going to run with a 2D signal as opposed to a 3D signal. That would be, in the examples here, a GC detector, like a FID with the universality of it, or an ECD, appreciating the sensitivity of that. So let me show you how we can give you a simplified presentation which will show you those signals, and then I'll walk you through the argument that there's a lot in common with mass spec quantitation, even though you've just got a 2D signal, because when you boil it down, once you've extracted the signal, quantitation is quantitation. You've got extraction, integration, you've got a calibration curve, maybe ISTD correction, you've got peak metrics, recoveries, and potentially even a continuing calibration workflow in GC. So I'll walk you through that with this example that shows the ECD detector with the PCBs. Well, you might not notice right away, but I've got an icon on my desktop which is 2D quantitative analysis. And it got there by my copying an existing icon and changing the properties. So if I look closely at these properties, you'll see that after quantanalysis.exe there's an argument minus instrument equals 2D. And that's what you need to do here in order to see this simplified presentation. So let me start this up, and this will start what I'll call a flavor that reduces the amount of mass spec information that would be shown and lets you focus on your 2D aspects of quantitation. So I'll load this PCB batch, and here you see the samples, and let's go through and take a quick look. Here I've got signal A, electron capture, calibration curve for it. If I move to the next, you'll see that this is channel B, so I've got basically a dual column setup. This is linked, so both signals are from the same sample and end up in the same data directory. So let's go next to the method editor and see how that's set up there. Alright, going over to the method editor, I can see with my compounds the set of compounds that I've been talking about. Let's take TCMX. You notice signal A, signal instance, the signal type is GC. If I look at my sample information, you can see no, I don't have a mass spec signal, but here in the extracted chromatogram I've got the signal B and the other signal from channel A, and those are extracted and shown here in the compound peak information. Now I do want to point out while I'm over here in the method editor that you've got these outliers, including all of the chromatography metrics that are very useful in 2D. Signal to noise, peak symmetry, front and back peak resolution, full width and half height maximum. You've got all these available, and nearly all of these are applicable, matrix spike surrogates, to the 2D quantitation. So let's go back now and look at a little quantitation. Alright, I'll just conclude here by showing you this 2D presentation in compounds at a glance. I've organized this so the blank is in the first column, and I can review all the way down. Each sample has its own column here. Now what I'll do for you is to link the y-axes, and you can see the blank is pretty blank, but I can look across these samples as I move down. I can see some higher concentrations here with DCB, and I can see a big picture of the batch, and I can move across all of the samples by moving horizontally, giving you an idea of the power of compounds at a glance. And if I want to manually integrate, I've got that right here with manually integrate or zero peaks.